Is steel more elastic than a rubber band? Let's talk about that. Hello guys, my name is Thomas and welcome to Mr. Padaku. If you like this video, don't forget to hit the like button, and if you like my content and want to support it, consider subscribing. So let's get started. To answer the question, is steel more elastic than rubber? We first need to understand what does the word elasticity mean. Well, many of us have a misconception that elasticity is whenever an object is able to be stretched a long distance, it is called elastic. Well, that's not right. Well, elasticity is the phenomena due to which when a force is applied on a material which causes deformation and the force is removed, the material regains its original state. Now, what would be the opposite of elastic? Well, it's plastic. For example, if we take clay, when we apply a deforming force on it or stretch it out, it stays in that same position. It does not go back to its original state. So, it's plastic. Now we know what's elastic and what's plastic. But how do you compare different materials depending on their elasticity? Well, you need two physical quantities: stress and strain. Stress is the force per unit area which causes deformation in the material, whereas strain is the amount of deformation which occurs on the material. There are majorly three types of stress: longitudinal, shear, and volumetric. So let's talk about that one by one. So first you have longitudinal stress. If you hang a heavy weight with a steel wire, you will notice after some time that the steel wire becomes longer. So force per unit area which causes change in the length of the material is called longitudinal stress. And the ratio of the change in length to the initial length is called longitudinal strain. Now, longitudinal stress can also be called tensile stress. If we take a metal cube which has joints on each of its vertices, and the bottom face is fixed to a particular platform. Now, if you apply a tangential force to one of its edges, you will notice that the whole cube shifts in the direction of the applied force. So, the stress which causes deformation in tangential direction to the surface is called shear or tangential stress. Now, the ratio of the tangential length to the amount of displacement of the surface is called tangential strain. Next, we have volumetrical stress. So, volumetrical stress or hydraulic stress. Now, you may have heard that as we go down underwater, the pressure increases. So, if we take a hollow metal cube and take it down slowly under the water, you will notice that the cube starts to be crushed due to the pressure. So, the volume of the cube is changing. The force per unit area which causes the change in its volume is called volumetric or hydraulic stress. And the ratio of the change in volume to the initial volume is called hydraulic strain. So now you know what are the different types of stress and the different types of strain. If an object could be stretched to any infinite amount, and whenever that force is removed, it would come back to its original state, we would call that object perfectly elastic. But in reality, there is no such object. Beyond a point, there is some amount of deformation which is caused to the material. Now, elasticity is defined by the material's modulus. So, modulus is the ratio of the stress to the strain. Hooke's law states that the stress applied on a material is directly proportional to the strain observed in the material. So, the more amount of force you apply, the more amount of change in its physical quantities you will observe. If we plot the graph between longitudinal stress and longitudinal strain, we observe it as an inclined line, but only till a certain point called the yield point. So if you look at this graph, you see that till point B, Hooke's law is applicable because the change in stress is directly proportional to the strain. But after that, the relationship between stress and strain is not constant. The stress at the yield point is called yield strength. So if stress beyond this point is applied, it would not obey Hooke's law. The stress that is applied at the yield point is called yield strength. If a force per unit area is applied beyond the yield stress, there would be some amount of deformation observed. After this point, the material starts to show plasticity. as in the deformation becomes permanent. But if you apply even more stress, there comes a point at which the material fractures or breaks. The stress at this point is called the ultimate tensile strength. For example, if you take a rubber band, if you stretch it a bit, leave the rubber band, it would regain its shape. But if you apply a large force and leave it, you would notice that there is some amount of deformation. Now, if you take the rubber band and constantly increase the amount of force you are applying it, there would be a point where you will feel that the material is starting to flow and it's easy to stretch. That means that you have crossed the yield point. And keep on stretching that rubber band even more and you will notice that it will break, which is very obvious. So now you know that you don't have a perfectly elastic object and you know what is elasticity. Now we can answer the question, why is steel more elastic than rubber? Because steel has a very large magnitude of yield strength, which means that if a large amount of stress is applied, after removal of the stress, it would regain its original shape. But this is not same with a rubber band. You'll notice that after stretching up a bit, it would start to break. So now you understand why steel is more elastic than strain, and you know of how the phenomena of elasticity works. So that's been my time, guys. So if you like this video, don't forget to hit the like button, and if you like my content and want to support it, consider subscribing. Never stop learning. Mr. Padaku signing off.